Hello everyone, you're welcome to this channel once again. Today we have another question from aerodynamics. Now let's read to the following question. Consider a Naca 2412 airfoil with a chord length of 0.64 meter in an airstream at standard sea level condition. The free stream velocity is 70 meters per second. The lift per unit span is 1254 Newton per meter. Calculate the angle of attack and the drag per unit span. Once again, consider a Naca 2412 airfoil with a chord length of 0.64 meter in an airstream at standard sea level conditions. The free stream velocity is 70 meters per second. The lift per unit span is 1254 Newton per meter. Calculate the angle of attack and drag per unit span. Today, we have a question bordering the Naca 2412 aerofoil with a given parameters, and we are asked to calculate the angle of attack, the drag per unit span, and the moment. Now let's assume we pull out all the parameters at standard sea levels. We know at standard sea level, the density at the standard sea level is 1.225 kilogram per meter cube. So therefore, the dynamic pressure equals half of the density to the product of the velocity. And we're given the velocity to be 70 meters per second. We're given the chord length of the Naca aerofoil to be 0.64, and we're given the lift per unit span to be 1254 Newton per meter. From here we can calculate the dynamic pressure to be 3,101.25 Newton per meter squared. Now that we have the dynamic pressure, the next thing is to calculate the coefficient of lift. And don't let us forget that coefficient of lift equals lift over the dynamic pressure, which is Q infinity, to the size of the aerofoil. Now we can deduce that this becomes L, that is the lift, over Q infinity multiplied by the chord length. That gives us our lift, which is 1254 over our calculated dynamic pressure, which is 3,001.25 times the chord length, which is 0.64. That gives us 0.65. Now from Naca 2412 table graph of the coefficient of lift to the angle of attack, we can deduce that by tracing the coefficient of lift of 0.65, we can deduce that the angle of attack equals 4 degrees. From here, we also know that at the standard sea level, the viscosity equals 1.789 to 10 to negative 5 kilogram per meter seconds. So by using all these values, we can deduce our Reynolds. So our Reynolds equals the density multiplied by the velocity, multiplied by the chord length of the airfoil over the viscosity. That gives us 1.225 times the velocity, which is 70, multiplied by the chord length, 0.64, over the viscosity under the standard sea level conditions, which were given here, which is 1.789 to 10 to -5. So our Reynolds number calculated equals 3.09 10 to -6. Now that we have found the Reynolds number, the next thing again is to trace the value from the table on the Reynolds number to the coefficient of drag. So by tracing from the table once again, you can deduce the coefficient of drag using the Reynolds number of 3.09 to 10 to -6 equals 0.0068. So our coefficient of drag from the table of Reynolds number to coefficient of drag equals 0.0068. So therefore, to calculate the drag from the following parameters, we can deduce the drag equation, that dynamic pressure multiplied by the size of the airfoil to the coefficient of drag. So that gives us our calculated dynamic pressure, which equals 3001.5 times 0.64 times 0.0068. Our drag on the airfoil equals 13.2 Newton per meter. That's the calculated drag. Now that we have found the calculated drag, the next thing is to calculate the moment per unit span on the airfoil. And to calculate the moment per unit span on this particular airfoil, we can trace the angle of attack on the moment using the table of moment to the angle of attack. We can deduce that the aerodynamic center from the table, that aerodynamic center gives the angle of attack to be -0.05. From there, you can deduce the moment per unit span to be dynamic pressure to the product of the size multiplied by the chord length at the moment multiplied by the aerodynamic center. So that gives us our calculated aerodynamic pressure, which is 3001.5 multiplied by the size of the chord length, which is 0.64, multiplied by the size again of the chord length, 0.64, multiplied by the by the angle of attack at the aerodynamic center, which is 0 - 0.05, in which this can be deduced from the table. So the moment per unit span becomes negative 61.8 Newton meter. Thank you for staying tuned.